Last section we're going to look at is called Exponential Growth and Exponential Decay. We're going to split growth up into 2 days, and we're going to split decay up into 2 days. All right, so this is the last section for this week. Thursday we're going to be doing MCAS, and we'll review for our test on Friday. Right, so every function has a certain, what we call form, okay, the way it looks. Does anybody remember what a line looks like? It was y equals, yeah, for a line we had y equals mx plus b. Okay? That's the form of a line, where m is your slope, b is your y-intercept. Well, this is the first time in this class we're going to get away from drawing things that are straight lines. Okay? We're actually going to sketch things that are curved.
Guys, on your note sheet, you want to put that, just like it is on the box there, you have a big box on your sheet, write that function right in there. You already have the y equals, write the a before the dot, write the b after the dot, and write the little x on top.
Okay. When we work with y equals mx plus b, what are the two letters that you have to figure out? No, not x and y.
B.
B, you need to know the y-intercept. And m. Okay, so when you write things in y equals mx plus b form, the two things that you have to find are the m and the b. Well, now we're going to write things in what are called exponential form. What do you notice is the same about each equation? They both start with what?
Y.
Yeah, they both start with y equals, but then after that things are different. Okay? This is what an exponential equation looks like. It's y equals a times b to the x. And the two letters you have to figure out are a and b. Just like the two letters you need to figure out are m and b. Okay? So we still use the letter b, but b is not going to be a y-intercept anymore. Okay? It's going to be something different. Okay? We write on the board, there's only one number a can't be. What number can a never be? Yeah, it can't be 0. Okay, you can pick any other number for a except 0.
Guys, you have a couple of bullets below what you wrote. That's already on there.
You broke it.
I got it.
All right, so here's an example of some exponential functions. Okay, notice what we wrote about b. b has to be a positive number. Okay? We're not going to talk about what happens when b is negative. Whether we're doing growth, which is things increasing, or decay, which is things decreasing, this always has to be true. Whatever number you put in for b, it's got to be positive, and it can't equal 1. Okay? Maybe later we'll look at why b can't equal 1. Okay? But just for now, I want you to understand it can't equal 1. Okay. Here's an example of an exponential growth equation. Y equals 3 times 2 to the x. Okay, let me show you a picture of it. Okay? For this one, not going to have you graph it by hand. I'm just going to show you what it looks like on the calculator. 3 times 2 to the x. Okay? So I just typed in that equation right there. Hit graph. And can you see it tracing it in blue? See what it looks like? It kind of looks flat for a while, and then all of a sudden it takes off and grows up very quickly. Okay? That's generally what exponential growth looks like. All right? Let's type this one in. Y equals 4 times 1/2, or I'm going to type 0.5 to the x. Okay? Show you a picture of this one. All right, let's get rid of that. 4 times 0.5 raised to the x. I typed 0.5 instead of 1/2 because it's easier for me on the calculator. And we get graph. And this one almost looks the opposite. It comes down very quickly and then looks like it flattens out. Okay? This is called not growth, but what do you think this one is? This is decay. And whether something is growth or decay all depends on the number that's right below the x. Okay? We're going to learn a pattern eventually, and maybe you can see the pattern, but we'll learn a pattern whether you can look at it and say, is it going to go up or is it going to go down? Okay? All depends on the number that's below x.
Guys, don't panic. We don't have like a scientific calculator. We're not going to ask you. Well, the way we ask you to graph them, you're not going to need a scientific calculator. You're going to be able to find some points, right? So don't worry about it. You're not going to have to do what Mr. Hager just did. You're not going to have to do that. He's just showing you what it looks like, right?
Yeah.
So don't panic. We don't have a calculator like that.
Okay, what did I say earlier about linear? What shape, if you draw something that's linear, what does that look like? A straight line. We're graphing things that are non-linear. Okay, so what that means, they're not lines. Okay? You just saw an example of what they look like. They're curved. Okay, that's a linear function. Okay, so some of what we do is we're going to look at a table. Okay, and there's going to be problems like this on the test, and you have to find a pattern. Okay, so what I've done is I pick some x values. I could pick any x values I want, but what's important when we look at it in a table, the x values all have to be 1 apart. Okay, and you'll see why that's important. And so I can't just pick -2, +30, -8.7. I've got to pick ones that are all 1 apart. Does everyone agree that -2, -1, 0, 1, and 2 are all 1 apart? Okay. So now let's look at our y values. Okay, what I'm going to do is plug each one of these in one at a time. And I'm just going to make a table, just like I was graphing. Okay? What's 3 times -2? -6. And what's -6 plus 2? Yep, -4. Now I'm going to fill in this next x value, and I'm going to see what y is. What's 3 times -1? Oh, Ben?
3 times -1 is 3. Or, yeah, -3.
Plus 2?
-1.
-1. Good. All right, let's plug in 0. Ryan, what's 3 times 0?
0.
Plus 2? Gives me 2. So I'm just making a little table of data so I can see the pattern. Logan, let's fill in 1. What's 3 times 1? Plus 2? Yeah, 5. Good job.
Guys, so you know, this is not the one that's on your sheet.
And the last one, Justin, what's 3 times 2?
3 times 2 is
Plus 2?
8.
8. Right. So there's our table. I want you guys to look at the y values. Does anybody notice a pattern? How you get from -1 to the number 2, how you get from 2 to 5, and then how you get from 5 to 8. What are you doing each time? Yeah, you're adding 3. It's going to give you a hint, but that's exactly it. You're adding 3 each time. Okay? So I want you to see that pattern. When something is linear, this is always the case. You add to get from one y value to the next y value. Add. Okay? We're going to see if that's what happens with the other kind of function we're learning today. I think it's going to be a little different.
When you said you had to add them, the one that's like on our papers.
Rosie, I just said that that's not on.
What?
I just said that that's not the one.
I know, but like, the one, can I figure out a pattern that it's multiplying rather than adding?
So that's what we're going to talk about next.
Oh, I had you, okay. I was like,
Look good
wait a
though.
minute.
So everybody sees that this is adding. Any question on that?
So,
Okay.
already had them.
So,
Yeah, so guys, that's what, like we did slope intercept, that's what we're looking at there, right? That's linear, when your y is added every time by the same number, all right? That's linear, that's all, Mr. Hager is just showing how, we're gonna show you how linear and how exponential are different, we'll use those same numbers, those same x values, -2, -1, 0, 1, 2, but something's different is going to happen with the y's. All right, so that's linear. We've already done linear, maybe not this way on a table, right? But Mr. Hager's trying to, we're going to show you guys the difference between linear and exponentials.
Right? And the important thing you have to do when you set these tables up, your x's have to go up by 1. So like Mr. Roy just said, we're always going to use these numbers.
Yeah, those 5 numbers, even when we do the stuff later today, always those numbers, every time.
So as x goes up by 1, you add a number, in this case 3, okay, to get to the next y value. Right? Now we're going to look at an exponential function. Okay, notice the x column, same numbers as we had before. They're all going up by 1s. Okay, let's fill out our y's together. Okay, I'm going to use a calculator to help us out a little bit. Somebody just tell me, what am I going to fill in for my first x value? What number? All right, so let me type this in on the calculator and see what it gives me. 2 times 3 to the -2, and I'm going to change it to a fraction, and I get 2 ninths.
Again, guys, this is just an example for you guys to see. It's not the one that's on your sheet, right? So don't worry about writing this down.
All right, now I'm going to fill in what for my next x value? I did -2. Now I'm going to do -1. Okay, so just change it. And I get the fractions. Anybody know what 0.6 repeating is?
2/3?
Yep, it's 2/3. If you have a calculator, either scientific or graphing, you can change it to a fraction. 2/3. Okay, now I think we're at the point we can probably do them in our head. Let's fill in 0. What's 3 to the 0 power? 1. And what's 1 times 2? 2. Let's fill in 1. What's 3 to the first power? 3 times 2? 6. And let's do one more. What's 3 to the second power? 9 times 2? 18. So, what's the pattern here? I just showed you, but how do you get from 2 to 6 and the same thing to get from 6 to 18? Yeah, you're timesing by 3. Okay? That's the whole key. Okay, when you look at a table, if you look at the y values, as your x's go up by 1s, if you multiply to get from one y value to the next, that's called exponential.
Are we supposed to be writing the words down over there?
No.
No? Okay.
What if you add to get to the next y value? That's not exponential, that's the one we just did before. What kind of graph is this one? Linear. Okay?
It's a straight line.
So as your x's go up by 1s, if you add to get to the next y value, it's linear. If you multiply to get to the next y value, it's exponential.
Guys, how many, be honest, how many people are confused, right? And it's, if you are, it's okay. How many people are confused on how we got these fractions? Raise your hand if you're confused. Okay. This is why we did negative exponents yesterday. All right, I'm plugging in, all right, -2 for x. When you're doing exponentials, all right, there's going to be the x is always going to be an exponent, right? Before when we did linear, x was always the slope. When we're doing exponentials, it's always going to be an exponent, all right? So 2 times 2 to the -2, all right? We don't have to do anything with that 2, right? But that 2 to the -2, what do I have to do to make it positive? Mr. Wright? Huh? 3, I'm sorry. We got 3 to the -2. All right? So, what do I have to do with that? Whoa. What do I have to do with that 3, or that exponent, to make it positive? We did this yesterday. Anybody remember? Huh? Put it over, okay, I'm going to start by putting it over 1, all right? So I'm going to have 2 times what needs to happen now? We got to flip it, right? So 1's going to go on the top. What's going to go on the bottom? 3 to the second, right? Now the variable, the exponent, becomes positive. All right, we got to simplify that more. It's going to become 1 over what? 9, right? Because 3 times 3 is 9. All right, so I can do 2 over 1 times 1 over 9. I can multiply straight across. 2 times 1, 2. 1 times 9, 9. That's how we got the 2 9ths. All right, that's why we did negative exponents yesterday. To show, because when you're doing your first couple, when we do these exponentials, the first couple of values that you pick are negative. All right, so you're gonna have to flip your fraction, right, to make that exponent positive. Right, that's the reason why. And if you can still if you put in like 2 on your calculator, 2 times parentheses 3 and parentheses, hit the button for exponents and put -2, it would still give you the answer. I'm just showing you that's how we got the 2 9ths. Right? We had to flip the fraction like we did yesterday. That's why we did negative exponents yesterday.
All right, so next thing we're going to look at is how do you create an exponential function from a table. Okay, so here's what a problem is going to look like. You can have that on your note sheet. You're going to have a table, and the directions are going to say write a rule for this table. In other words, a formula. Okay, so that you give me a formula, and I could plug it in and graph it if I wanted to. All right. So these are the 2 things we need to know. Okay. In the equation y equals ab to the x, y is going to stay, x is going to stay. Right? The only 2 letters that we have to figure out is a and b. Now, exponential functions can be tricky. But the kind that we're going to give you, you're always going to be able to do these directions. Okay? There are certain kind of exponential problems you might study in Algebra 1b or Algebra 2. These directions wouldn't quite work. But we're going to give you simple kinds of exponential problems to start with. Okay? We're not going to give you complicated ones.
So guys, on your note sheet, on the guided notes there, you have the box where you just put the exponential function. Right, the formula for the exponential function. You have a couple arrows. When we set up from a table, right, y is going to stay as y, just like it would in a linear. X is going to stay, and it's not going to be attached. It's going to be an exponent rather than a whole number. It's just going to stay as y. Those 2 letters always stay as letters. They don't change. Yeah, the a. Yeah, so you're going to write on your arrows on your sheet. You're going to write y stays as y and x stays as x. Those just stay as letters. When we set this up, they're going to stay as letters. All right. Then I think on your thing it says a is, below that you have a is and you have a long line. Write the y value of the function when x equals 0. All right. If you don't know what that means, that's okay, because we haven't done one yet. All right. When we do the next example, that'll make a little bit more sense. All right. So a is going to be the y value of the function when x equals 0. Right? B is going to be what you multiply each value by as x increases. Right? Just like when we had to find the slope, right? We plugged in the number with x was always the slope. All right? Just like we've done before. Okay? But again, y stays as y, x stays as x. The only thing that will be numbers is the a and the b. And when we look at that next table, right? Example 1, it'll make a little bit more sense to you guys.
Okay, so these 2 directions are basically telling you how you get your A and how you get your B. All right, so we'll go through how this works.
Yeah, we're going to look at that table, that example 1, the table for example 1, and we're going to use that function y equals a bx, and from the table, plug in a number for a, plug in a number for b. Then we're done. That's it. That's all we're doing.
So what's my equation for an exponential function? Can somebody just remind me? It's not y equals mx plus b. Yep. So we're going to start with that. Y equals a times b to the x. 2 letters I need to find are what? I need to figure out a and b. It says to find a, It's the y value when x is 0. Okay, so look at your table. Find where x is 0 in that table, and tell me what's the y value when x is 0. 8. So that tells me a is what number? 8. Okay, so a is 8. Now it says b is what you multiply by each time to get to the next y value. So first, look at your x's. Are your x's increasing by 1? Yes. If they weren't, then you can't use this trick. Okay, but they are, and they always will be in this class. So your x's are increasing by 1. What are you multiplying by to get from 2 to 4? Yep.
By 2.
Multiply by 2. What are you multiplying by to get from 4 to 8?
2.
Times 2. How about 8 to 16?
2.
All right, so I think we can see the pattern. We're multiplying by 2 each time. So, what you multiply by each time is what letter?
B.
B is what you multiply each y value by. So in this case, B is 2. Now, just fill in 8 for A, fill in 2 for B, and we're done. So y equals 8 times 2 to the x.
So can you just go back for 1 second? Guys, as I'm walking around, I see a lot of people that don't have this, all right? On your thing, it says A is, then it's a long line, a long blank. Same thing for B. B is, there's a long line, if there's a blank. If you don't write these notes down, you're not going to have any idea what we're doing. I know it's 8:30, I understand it's the end of the school year, but you need to get this stuff written down. All right, where it says A is, you're going to write the y value of the function when x equals 0. Then it says B is what you multiply each y value by as x increases by 1. Right, if you don't, as I'm walking around, I know most of you guys might have, with a couple people I've looked at so far, they don't have that. So you want to get that written down. All right, then I'm going to explain to you what else you need to write. Yes. Good.
Okay, does everybody have that?
I know Mr. Hager minimized it there for a second, so some of you guys might not be able to see it. All right, but make sure you get that written down. All right. And then,
Any questions on how we got y equals? Somebody tell me, where'd the 8 come from? Let's scroll up a little bit.
Table.
Yep, and how'd you figure it out looking at the table?
0.
You looked at when x is 0, and then you looked for?
When it's like possible.
So how come you didn't write 0 for A then?
Because it's what y is.
Yeah, it's what y equals. So you look at that column where x is 0, go down to y, there's your A. How about this 2? How'd we get that?
That's the pattern for y.
The pattern, yeah, it's what you multiply by each time. Okay.
We had 3 8s again.
All right, the 8, you look at when x is 0, find the y value. That's A.
Oh.
When x is 0, look at the y value.
look at 0 and just look what's below it. Whatever below it, that's what your A is going to be. So on your sheet for that first example, you have y equals. You want to write 8 times x to the second.
2 to the second, 2 to the x.
2 to the x. I'm sorry. So you want to write y equals 8 times 2 to the x. If you don't have that.
All right, well, let's take a look at this one. Okay, first thing you should check in your table, are your x's going up by 1?
What?
Yep. If your x's are going up by 1, you can use those 2 tricks. Okay, anybody think they can tell me what A is going to be here? 27? And can you tell me how you got that? All right, how come though? It's the y value when x is 0. All right, and how about B? Yeah, Kevin? Okay, guys, please be quiet. I'm trying to hear Kevin. Yeah, Kevin? How'd you get 3? How'd you figure that out? Yeah, if you multiply 3 by 3, you get 9. If you do 9 times 3, you get 27. If you multiply 27 times 3, you get 81. So that tells us b is 3. So who can tell me what my rule would be for that function?
Y equals 27 times 3 to the x.
Yep, times 3 to the x. Perfect. You don't do anything else with that. Okay? I think in the past, I've seen some people do 27 times 3. You can't do that. So don't try to do that.
Remember, y stays as y, x stays as x. The only thing you're plugging numbers in for is your a and your b.
Okay, and notice, look how quick this function goes up. If you look at your y values, they start at 3, then they go to 9, 27, 81, 243. Pretty soon it's already going to be in the thousands, and x is only going to be like 4 or 5. So exponential functions go up very quick. And they can also come down very quick.
And guys, some of these that you might do, like the first y value might be a fraction. Right? You might get a fraction for the first y value. That's okay. Right? So that's okay. If you're not sure what you're multiplying the fraction by to go to the next y value, look at the whole numbers. You can figure those out. All right? Look at those. It makes it a little bit easier.
All right, so the next kind of problem we're going to do is basically we're just going to give you the function, all right? And we're going to try to graph it. Okay, we're going to try to make a graph from a table of data. But we'll give you a formula to start with. All right, so step 1. You have to pick some x values.
So we're on the back side now, guys.
These are the x values that we suggest you pick. Technically, you can pick any x value you want. The problem is going to be is if you let x get too big, look at what happens to your y values. You're going to go off your chart. Okay, so we're going to try to pick x values between -2 and 2, okay, going by ones.
So you're right. Number 1 on your steps, you're going to plug in -2, -1, 0, 1, and 2 in the x row. Because if you guys look below that, the example that we do, all right, there's an x row. You're just going to write, every time we do one of those, you're going to write those numbers in for x, right? You're going to write those same numbers in. Then you'll do the math, all right? When you plug those numbers in for the x exponent, what are you going to get? That's going to allow you to solve for y. And remember your negative exponent rules. Like I showed you, the first one Mr. Hager did, we had to flip some stuff around. Right? You might have to do that. And sometimes when you do that, you're probably going to start off with fractions.
Right, so what Mr. Roy just explained, that's step 2. You got your x values, now you're going to find all your y values. Once you have an x value and a y value, we can put them together. And what do you call it when you put an x value with a y value together like this? What is this thing called? It's a coordinate. Okay. Now, once you have coordinates, you'll have points, and coordinates allow you to draw a picture. Okay. So after you have your coordinates, you need to graph them. And the graph, again, it will be curved. Okay. You're going to notice that it usually takes a very sharp turn up very, very quickly. Okay, so the first one we're going to look at is y equals 2 to the x. I know some of you have graphing calculators. On this kind of problem, we wouldn't even allow you to use one. Okay, I think Logan, you have one, right?
Yeah.
Okay, so on this kind of problem, even if you have one, you can't use it on the test. I don't think anybody else has one anyway. But. Okay, does everybody have up to step 3, at least? Scroll up.
All right, so guys, when Mr. Hager's doing that, right, what's the first thing, who's everybody raising their hand? What's the first thing that he should do? Rosie,
Fill in the X column,
what should you put?
-2 through 2.
-1, yeah. Every time use those numbers. It's gonna make your answers a little bit easier. All right? What's he gonna do now? You can tell me. Some besides Rose, but thank you, Rose. Sabrina, what do you think?
Solve for y.
He's gonna solve for y, but how's he gonna do that? What's he gonna do with those x's? Where do you know? Plug in for x, right? So the first problem he's gonna get is y equals what? He doesn't write y equals. Yeah, y equals 2 to the -2. What's it? Gage, what's the next problem going to be that Mr. Hager writes? He just did 2 to the -2. What's he going to do now?
2 to the -1.
2 to the -1. Good. Caitlin, what's the next one he's going to do?
2 to the 0.
2 to the 0. Good. Zach, what's the next one he's going to do?
2 to the 1.
2 to the 1. Good. Victor, what's the last one he's going to do? He just did 2 to the -2, 2 to the -1, 2 to the 0, 2 to the first. What's he going to do now? 2 to the second. Yeah. All we'll do is take in those x values and plug them in for the exponent. That's x. Right? Then we'll solve.
Right, so how am I going to do 2 to the -2?
You do 2 times 2. Oh, -2.
Yeah, careful. What is that? What kind of number do we end up with when we have a negative? A decimal or a fraction? Yep. So think of that 2 to the -2 is in the top. Where does it have to go? Yep.
Good.
So it's going to go into the bottom. What's going to be left in the top? Just a 1. And anybody tell me what is 2 to the second power?
I got 0.25, so it'll be 1/4.
Yep. 0.25 or 1/4. How about 2 to the -1? What kind of number is that going to be? Is it a integer or is it a fraction? Yep, another fraction. What's in the top? 1. What's in the bottom this time? 2. Good. That's our last fraction. All right, what's 2 to the 0 power? 1. What's 2 to the first power? And 2 to the second? 4. Okay, let's graph those points. Actually, let's make our coordinate first. Fill in your x's. And now it says also to fill in your y's. Those are all the numbers we just did in the second column. My first y value is 1/4. Second y value, 1/2. Third y value is 1. My fourth y value was 2. And my last y value, 4. Great, let's graph the points and see what it looks like. So we got -2, 1/4. Okay, just estimate it as good as you can. It's pretty low. -1, 1/2. So it should be halfway up. 0, we're at 1. 1, 2. Okay, how do I graph the point 1, 2? Starting from the origin, what direction do I go? Right 1. Up 2. Yep. Okay, you should start to be seeing that curve happen. And who can tell me, how do I graph the last point? 2, 4. Ryan? Tell me how I graph 2, 4.
You go to the right 2, then the up 4.
Yep.
Their graph is a little bit different. It's got the x-axis is down low, and then the y-axis is to the left.
Oh, that's okay. Right, and now when you draw it, this is your sketch. Just draw it very close to that line, almost horizontal, and then have it curve up. And that's your sketch. Okay, any questions on that? Okay, how do you guys feel about graphing an exponential function? Like, it seems okay? Kind of okay, it takes a little practice. Right, we're gonna look at a few graphs now. I'm not gonna have you do them all by hand, but we're gonna look at what happens when you change that number a. Okay, like when we change y equals mx plus b, we know if we change b, it changes the y-intercept. We know if we change m, that's the slope. That's how steep the line is. Well, what do the a and the b really do? Okay, in a graph that curves like this, if you make a bigger, what happens? Okay, so that's what we're going to take a look at. Okay, I'm not sure. Do they have this on their example sheet, Mr. Roy?
No.
Right. So I just want you to watch me compare
I
these.
think I changed that when I sent it to you.
All right. So here's.
No, we have it.
You have it.
You have those, they just don't have the pictures, Mr. Hager.
Okay.
Not the exact.
Not the exact. Okay. So here's the picture you guys just did. Y equals 2 to the x. Okay.
Guys, they don't have this on the sheet, just pay attention, okay?
Y equals 2 to the x. That's the picture we just did. I'm just going to save a little time rather than drawing it again. I'm going to use my calculator. And I'm going to show you a few other graphs. I want to look at what happens when I put a 3 in front of it, and then when I put a -3 in front of it. Does anybody have a guess what's going to happen when you put a 3 in front of the 2? It's going to change the picture a little bit. Anyone have a guess how it's going to change? Right? Let's take a look at it. That's 2 to the x. Here's what happens if you put a 3 in front. Okay? I still kept the original, so you could see the one in blue. Blue is y equals 2 to the x. Red is y equals 3 to the x. Looking at the picture, what did putting a 3 in, what did that cause the graph to do? It what? Yeah, it went up faster. Okay, putting a 3 in front causes the curve, I guess you could kind of think of it as taking off sooner, right? Think of it that way. The red curve is taking off sooner. Okay? In fact, the bigger number that I put in front, the faster it takes off. Okay, so if I put, instead of a 3, if I put like a 30, this graph would take off even sooner. Okay, it would go up quicker. All right, so that's what putting a 3 in front does, or a 4 or 5. How about a negative number? Anybody have a guess what that negative is going to do? It's going to cause the picture to do something. Yeah?
More. Less sooner.
Go up. Oh, you mean kind of curve up maybe later?
Yeah.
That's a good guess. But it's not going to curve. It's not going to cause it to curve later. Yeah?
It's going to cause it to go down.
Yeah. What the negative does, we call that a flip. It's a mirror image. All right. So here's the one in blue. Here's the one in black. You can kind of see if you took and flipped it, just take and go like that, it would land on the bottom. All right. So we're going to summarize what those two things are. Okay, negative causes your graph to flip, causes it to flip over. 3, or a number in front, causes it to go up sooner. We call that stretching it. Okay, if you stretch it, it curves up sooner. All right, so these are the two things you want to write down. This is on your note sheet. This is your exponential function. And this first thing I've highlighted in yellow, I'm talking about this number in front. if you put a number in front that's bigger than 1, okay, I did 3 with you guys. I could have done 4. I could have done 6, 12. Pick any number you want bigger than 1. That causes the graph to stretch. Okay, the way Sabrina said it was, she said it curved up sooner. Yeah, the same thing. Okay, stretching it vertically, curving up sooner, same thing. Okay, and the way that you describe it, what we're going to ask you for on the test, is these exact words. We say that it's called a vertical stretch by a factor of, and then you fill in whatever A is. Okay, so let's say you had something like this. Y equals 2 to the x. Y equals 3 times 2 to the x. If this was on the test and I asked you to compare these two graphs, this 3, it's bigger than 1, right? So it's stretched vertically by a factor of 3. Okay? That's how you would compare these two graphs.
That's what you write, guys. You just write vertical stretch by a factor of 3. That would be your answer.
Because everything else is the same in the graphs. The y's are the same, the equals are the same, the 2 to the x is the same. It's just this one has a 3, this one doesn't have a 3. All right? So that's what putting a number in front does. It causes a vertical stretch. What did we say happened when A was negative? It caused the picture to do what? Flip. Okay? This causes your graph to flip over the x-axis. Okay? So if you had a picture that looked like this, the mirror image of it would look like, kind of like that. That's a flip. Okay. And the way that you would say this one is if A is negative, okay, so if you had something like this versus something like this, actually let's make it even simpler. Y equals 2 to the x, y equals negative 2 to the x, and I asked you to describe these two graphs, we would say the second one is a reflection of the first one. A reflection over the x-axis, okay, because of that negative. All right, now, let's say you had something like this, and you had something like that. There's two things happening. Who can tell me what the 3 does? What's that word we use to describe it? Just the 3, not the negative. The 3 is a vertical stretch by how much? 3. This is a vertical stretch by 3. That's the first thing. And now, what's the negative going to cause to happen? That's going to cause a reflection. All right, so sometimes you can have both of these in the same problem. Okay? The number in front causes a vertical stretch. The negative causes a flip. All right, so we'll look at 2 examples where you just describe what's happening, and then we'll be all done. Example 5a says, I'd like you to compare the graph of y equals 4 times 2 to the x with the graph of y equals 2 to the x. So if you compare these, everything is the same except one number. What's the only thing that's different between these two? Oh, Ryan?
The 4.
Yep. Perfect. There's a 4 in front of the 2. Who remembers what putting a number in front does? Bigger than 1. Yep. Putting the 4 in front, it's going to cause a vertical stretch. So we're going to start by writing that down. Vertical stretch. Now, we have to be a little more specific. You have to tell me how much of a vertical stretch. Okay, so vertical stretch by a factor of how much? 4. That's it. That's all you have to write. This graph is a vertical stretch of this graph by a factor of 4. That's it. Okay. Any questions on how we did that? It's a vertical stretch by a factor of 4. Right? Let's try this one. Yeah, there's two things happening, right? So Corey picked up on the negative. That's a reflection. And there's a 3. So I got to describe what both the 3 is going to do and what the negative is going to do. They're separate. Okay, who can tell me what's the 3 going to do? Good, you guys getting it? Vertical stretch by a factor of 3. Okay, that's the first thing. And Corey gave us a hint. What's that negative going to do? It's going to reflect. And over which axis is it going to reflect? Yes, reflect over x-axis. So sometimes it's just a stretch. Sometimes it's just a reflect. Sometimes it's both. In this case, it was both.
So can they say a vertical stretch by a factor of 3 reflected over the x-axis?
If you wanted to make one big sentence, you could make one big sentence like that. That's perfect too.
Okay.
Yep.
Remember, don't say a vertical stretch by a factor of negative 3.
Yes, don't do that.
You want it to be positive.
I want you to think of the 3 and the negatives separate.
Vertical stretch by a factor of 3, and because it's negative, you reflect it over the y-axis. That's how you take care of it.
X-axis.
X-axis.
We are going to talk about reflecting over the y-axis too, but not today. Okay. So any questions on how you identify what the number in front does or what the negative does? All right. So couple reminders. Second to last test this Friday. Okay. MCAS review day on Thursday, and progress reports also close on Friday. Okay. On the progress reports, there will only be 2 tests. Okay. Homework tonight will be a worksheet on 8.5.
Guys, don't pack up.
And we're going to have you guys practice some review problems now.